Hey, ladies and germs, let's talk some rates. First thing you have to kind of decide, first of all, is what in the world is this unit rate talking about? And when I say unit rate, I mean reduce so the denominator is 1. Hopefully you guys watched that really quick video I posted as well on this sheet about unit rate. It'll give you a good idea what in the world I meant by unit rate. And how we're going to handle this problem or how handle this page. So anyway, let's get into it. So consider the relationship representing each scale. Describe the relationship as a rate using the names of fruits as the units. So we need a rate, but specifically we need a unit rate. We're going to do both. But let's just get to it. The scale indicates that blank strawberries balance blank apples. Well, we're just going to be doing a quick count here, and hopefully you guys are noticing 1, 2, 3, 4 four of them bad boys on the strawberry side of things is going to balance one of them apples right here on the apple side of things. And they are balanced, of course, because they're the same weight. So it's important to note that the way they have this written, strawberry slash apples, and I'm looking right here if you want to direct your attention, that's the same exact thing as, and I'm going to write this above, as strawberries over apples. In fact, the way I'm writing it right now is probably a more natural way to write it because it gives us a clear top numerator and bottom denominator. So if I just transfer the numbers I have here to my new structure, strawberries are on top, that's 4, apples on bottom, that's 1. And so that's going to be my rate. So my rate is actually at this point 4 strawberries. 4 strawberries for every 1 apple. Now this turns out to be a unit rate, again, because you watched that unit rate video before. The unit rate is always going to be where the bottom is 1, or you're taking something per 1 of something else. So we can actually just write this as a 4 strawberries per apple. Sometimes it ends up being a decimal point. Sometimes it ends up being just a whole number like I have here. Anyway, let's get to the next one. So this scale indicates that some amount of limes balance some amount of apples. Well, here I have 2 limes, so I'm going to go ahead and record that as a 2. Oh, not there though, right there. So 2 limes, and of course we have Mr. 1 apple here. So they're not so kind as to put in the units for us, but we're going to go ahead and do that right now. Again, I'm going to write it above. I'm going to choose to go limes over apples. Now the reason I'm doing this is because I know I have to write a unit rate. I know if I transfer 2 limes to 1 apples, again, unit rate always being over 1, it's already in the unit rate form. So 2 over 1, 2 divided by 1 ends up being a 2. Limes over apples, and I'll write it like they did, limes slash apples, limes per apple. And that's an important part of understanding unit rate is that that's how we get to use the per language. Per indicates 1, so like the term PER, it implies per every 1. So miles per hour, that's miles per 1 hour. Drinks per minute is drinks per 1 minute. Okay. Anyway, let's keep rocking and rolling. You guys are doing good, I think. Hopefully, if you're watching this, you gotta be doing better than that. Use the information from the 2 balances pictured in problem 1. Write another rate. Sketch a new balance scale that represents this rate. So we just actually get to pick, and this is exciting. So I'm gonna pick. I'm gonna actually make this one really difficult. I'm gonna pick what my strawberries are gonna be really bad. I'm just gonna draw triangles. So 1, 2, 3, 4 strawberries, and that's what those are, believe it or not, strawberries. And then over here, I'm gonna pick 2 oranges. Now, before you question why I chose purple for strawberries when I could have chose red, the answer is I don't know. So let's go ahead and write this in as a rate. So I have 4 strawberries for every 2 oranges. But now I actually need as a unit rate, and again, a unit rate is actually over 1. So the way we're going to accomplish this is by actually dividing these 2 numbers. So we're going to take 4 divided by 2 and end up with 2. And then we have strawberries over oranges. So I'll abbreviate strawberries over oranges. Okay, and again, the way we're actually converting this unit rate is to realize that 4 divided by 2 is the same thing as 2 divided by 1, which is the same thing as 2. All right? And then we're continuing. Okay, so use the scale picture below. Oh my goodness, 2 oranges. I almost got it. Use the scale picture below to complete the table and sketch the graph of the relationship of the limes and oranges. All right, I could do that. Okay, so we have 3 limes. I'm going to write over here. So we have 3 limes for every 2 oranges. And now we have to change things around. Well, if I had three, and it actually belongs in your table as well. So if I put in the 3 limes and 2 oranges, that might help us see what to do next. Because since I doubled it to 6, I should have to now double to 4. Okay? So 6 limes, 4 oranges. Now we got to be careful on this because it's easy to just be like, well, I gotta go up a couple more here, or go up 3, so this goes up 2 on the right. But that's not actually the case. What we have to look at is from our original rate. So we started out with 3, we doubled it to get 6. Now we're tripling it times 3 to get to 9, which means I have to triple this guy as well times 3 as I actually being 6. Now it does end up falling in the pattern, which is totally okay. I'm not saying it shouldn't have. What I am saying is that when we're dealing with rates, we need to think about our original rate. All right. So I'm going to erase a little bit here. Well, actually, let me just go to a different color. So that's how we're actually going to figure out to 10. So check this out. If we go from 2 and we bump it all the way to 10, that's a times 5. So on the other side, we're going to have to do the same thing. 3, bump it all the way to times 5. Okay, and 3 times 5 will give us 15. Right? So again, we're just going to keep playing this game. And we can play this game on a lot of different levels. So like, check this out. Here's what I mean. Here's 10, here's 20. That doubled, right? So 15 double that should give me my value. 15 double that should give me 30. Bam. Okay. Again, let's play that game. So check this out. If I take 2 and cut it in half, divide by 2, I end up with 1. So that means if I take this 3 and divide by 2, I should get 1.5. And the last one, 3, kick it all the way over, divide by 3 gets me that 1. So this 2 won't divide by 3, because I do the same thing on both sides, will give me a 0.66, and I'll write it as 2/3, because that's an easier way to write it for me. Okay? So the key to understanding this problem is that excuse me. The key to understanding this problem is that we always have to start with the original rate and then transfer by multiplication or division to the other rates. It's not like a normal table, and that's something really important to note here. This is not like a normal table. It's playing by a kind of different set of rules for a lot of different reasons, right? Anyway, so let's go ahead and write these 2 unit rates. So limes, oranges. So limes over oranges. So the unit rate we're looking for is actually right here. I have 1.5 limes per orange. Or here, switching it around, I actually have the opposite. I have 2/3 of an orange per lime, and I'm grabbing those right from my table, right? Because again, unit rate is always going to be over 1. So if we're going to sketch this out, oh man, I'm running out of colors. We don't really know which one belongs on top, limes or oranges. So we don't really have a clear sense which one should be X. But just using our standard table alignment, I'm going to go ahead and make this guy here limes, which will make this guy here oranges. Okay. And I'm going to go ahead and reset my axis because I drew all over the place. I'll make that my new y-axis. And I'll make that my x-axis. Okay, so let's figure out what we have to count by. Well, I'm looking at my line part of the table, and I see the biggest number that I actually have to get to. So I'm looking at my limes. The biggest number I have to get to is 30. Man, that's going to be tough to count by, but we'll make it happen. So if I have to count to 30, let's just kind of test some stuff out. Let's see what we got. Let's see, 5, 10, 15, 20, 25, 30. So I can count by 5s and get to there. Sorry about that. Let's see what else we can count by. Let's see, 2, 4, 6, 8, 10, 12, 6. So 2s won't quite get there. But 3s. So if I made that 3, 6, 9, 12, 15, yeah, I think this will work. 18, 21, 24, 27, here's my 30, 33, 36. Okay, good. So counting by 3s, we're good for the limes. Now let's take a look at our orange table, or orange part of the table, I should say. The biggest number I got to get to on that one is, looks like 20. Okay. So looks like we can count by just about anything to get to 20. I bet we can even count by ones. 18, 19. Oh, so close. But I might go ahead and count by ones anyway. We should make 20 about right there. All right, so now let's go ahead and graph these pairs. I'll graph mine in purple. All right, so the first one is 6 limes to 4 oranges. So 6 limes, 4 oranges. 9 limes, 6 oranges. So 9, 4, 6. We have 15 and 10. 7, 8, 9, 10. We have 30 and 20. 1.5 and 1. And then 1 and 2/3. Okay. So I made a statement earlier that this table kind of plays by different rules, which is kind of actually false. I kind of made that statement intentionally false for you guys, because if you're looking at the graph now, you can hopefully definitely see that it's a linear relationship, meaning that there should be a definite rate that takes this that takes this table up and down. And we actually explore that right there with the units. Last part about this, the school district in which Mr. Robles teaches provides 8 whiteboards for a class of 24 students. Use this information to write the questions, to answer questions in the chart. And I think I'm going to try to do some of the work actually a little bit outside the chart as well. Okay. So what's the unit rate of students per whiteboard? So on the left-hand side here, it's important to note that when they say students per whiteboard, and I'll use S for students and W for whiteboard, that the rate is actually going to be S over W. So with that in mind, consider this. We were told that there's 8 whiteboards for 24 students. So to continue our rate, that would be 24 students for every 8 whiteboards. That's not a unit rate because it's not reduced down to per 1 whiteboard. Now we can do that by simply taking 24 divided by 8 and making that a 3 students. Well, that's the way that's written. Hold on. So if we take 24 divided by 8, we end up with 3 students for every 1 whiteboard. Which, if I want to take that to a unit rate, I'll just say 3 students per whiteboard. Okay. So again, the unit rate is really just a reduction of the rate that numbers you've been given. So in other words, actually do the division problem. Let's go ahead and see another example here. Let's change colors into, like, say, a purplish. Here we want whiteboards per student. So the rate we're looking for is going to be whiteboards per student. And again, we can take those numbers directly from our problem. We have 8 whiteboards, 24 students. So that's going to be 8 over 24. So again, here the unit rate, we've got to be careful because we have to reduce it so it's over 1. In other words, we have to execute this division problem. So if I take 8 divided by 24 and reduce it, I'll actually have 1 over 3. So 1 whiteboard for every 3 students. But that's not how the unit rate has to be represented. It has to be over 1. So I can actually take this as a third whiteboards per student, or 0.33 if you want to write it that way. Okay, so assume the rate stays the same. How many students are there if the district provides 32 whiteboards? Okay, so let's take a look here. We have 3 students per whiteboard. And they want to provide 32 whiteboards, so multiply that by 32. Yeah, because if there are 3 students per whiteboard, and there are 32 whiteboards, there'd be 3 times as many students. So that'd be what, 96? So over here as well, let's recall that we have 1 whiteboard for every 3 students. And now we want to provide for 96 students. So there should be a third as many whiteboards. In other words, we multiply again. And look at this. It's going to be 32 whiteboards. Okay, assume the unit rate stays the same. How many students are there if district provides 4 whiteboards? Well, 3 students for every 1 whiteboard. And you just said there are 4 whiteboards. That means there's got to be 12 students. And again, we're executing a multiplication problem. Assume the unit rate stays the same from the previous problem. So we have 1 whiteboard for every 3 students, and now we have 12 students, so there should be a third as many whiteboards. So 12 divided by 3 will give us 4. And again, we're looking, I don't know if you guys are noticing this, but on the left hand and the right side, it seems like we're kind of reversing ourselves a lot. Hopefully you guys are seeing that there's a change. Here we have, let me make it more obvious. It's like over here we had 3, over here we had 1/3. We have 96 that came from 32. We have 96 that came from 32. We have a times 4 making it a 12. We have a times 12 making it a 4. So definitely there's something going on with these rates side to side. So as you guys are comparing these answers in 2, go ahead and make your observations about what you notice, right? So this was designed to help you if you're really struggling. Hopefully this helped. I'll see you guys tomorrow.